Alright, so this is problem 10. Problem 10 states, if f of x is equal to this function, then which of the following statements is or are true? So we have three statements here. We have P, the graph of f of x has horizontal tangent lines at x equals 0 and 12. We have statement Q, the graph of f of x has inflection points at x equals 0 and x equals 9. And statement R reads, f of x is both decreasing and concave down on the interval 0 to 9 only. Okay, so recall a few things here. Wrote down, horizontal tangent line means m is equal to 0, but if m is equal to 0, then it means that the derivative is equal to 0. Once we do that, we can solve for the x values, and we can see if those x values are the ones that give the slope 0. In this case, 0 to 12. Also, inflection points. In order for a function to have an inflection point, the function must go from concave up to concave down, or vice versa on that interval. So in order to test that, we would pretty much take the second derivative, do the second derivative test, and for concavity, and if f double prime evaluated at some x is less than 0, then this implies that it's concave down on that interval. And if you have f double prime valued at 0 and that's greater than 0, and this implies it's concave up on that interval that you're testing. Okay, so we're going to use this fact. Alright, so let's go ahead and start checking out each statement, see if each statement is true or which statements are true and which statements are false. So let's go ahead and work with statement P. So the graph of f of x has horizontal tangent lines at x equals 0 and equals. Okay, so we need to take the first derivative of f. So f prime of x using the power rule. Bring the 5 down, the 5 cancels, you're left with x to the 4th. Here we're left with minus 12x to the 3rd by using the power rule again. And the derivative of 6, the constant, is 0. Alright, let's go ahead and simplify this, because we want to equate this to 0. So we can factor out, I missed something, no, okay, that's fine. Now we want to factor out an x to the cube. So we have x minus 12. And now that that's factored out, we can go ahead and equate that to 0. So that equals to 0. If we do that, we obtain that x cubed is equal to 0, or that x minus 12 is equal to 0 by the 0 factor property. So now we get that x is equal to 0. Take the cube root of both sides, you get 0. And here we get that x is equal to 12. So x equals 0 and x equals 12, those x values are where you have a horizontal tangent line. So is this true? Horizontal lines at x equals, yes, that's true. So P is true. Alright, let's work with Q now. Alright, let me just, this is too big here. Alright, so Q. So now, I want to find, okay, the graph of f has inflection points at x equals 0 and x equals 9. So remember, we want to take the second derivative test and see if it's greater than 0 or less than 0, and if it goes from concave up to concave down on those intervals, then there is an inflection point at that P. Alright, so find f double prime. So double prime, that's going to be 4x cubed. 4x cubed minus 36x squared. Alright, so let's do some simplification here. We can factor this out. Factor out a 4x squared. We're left with x minus 9. Okay, so we have factored that out. Now we equate this to 0. So now I want to find this is equal to 0. So these will be our critical points for f double prime. Set 4x squared equal to 0, and set x minus 9 equal to 0. Again, something times something, 0 factor property. This equals 0, this equals 0. So we get that x is equal to 0 here, and we get that x is equal to 9. Alright, so we have x equals 0 and x equals 9. That's good, x equals 0 and x equals 9. But we can't automatically say there's inflection points there. We have to go ahead and test them. So how do we do that? Let's draw a number line so we can visually see this, what's going on. Go ahead and put your critical points, 0 and 9 for the second derivative, and let's do some test points. So let's pick -1, let's pick 1, 1, let's pick 10. So we're going to go ahead and plug in these test points into the second derivative and see what happens. So we're just looking for the signs here, remember, because we want to find if f double prime is less than 0, f double prime is greater than 0, because that tells us if it's concave up or concave down on that given interval. Alright, so f double prime of negative 1. Is this a positive or a negative? Okay, that's going to be positive, but negative 1 minus 10 is negative, and negative 10 is a positive is a negative, so that's a negative number. So that means this is concave down on negative theta 0. Now, f double prime of 1, what's that? So f double prime of 1, plug in 1 in here, you get positive, and then here you get negative, so negative times a positive is a negative. It's not a negative number. So that means you have concave down from 0 to 9. And now f double prime of 10. So f double prime of 10, what's f double prime of 10? 10 minus 9 is a positive 1, and that's positive, so positive times positive is a positive number. That's a positive number, so that means it's opening up. Okay, so remember what inflection points are. In order to have an inflection point, the function must go from concave up to concave down, or concave down to concave up. So if you look at here, from negative theta to 0, this is concave down, and then from 0 to 9, it's still concave down. So it did not change from concave down to concave up. Therefore, at 0, there's no inflection point. And this statement is stating that there is an inflection point at 0, and that's false. So therefore, this whole statement is false. Because even though there is an inflection point at 9, because this is going from concave down to concave up, there is no inflection point at 0, because it stays concave down to concave down. So that statement is false. So Q is false. P true, Q false. Let's work with R now. So R. Let's get some space here. Alright, so R. F of x is both decreasing and concave down on the interval 0 to 9 only. Alright, well we can already agree with concave down on the interval 0 to 9 only. We know from 0 to 9 it's already concave down. We already computed that, we already saw that. What we need to see is if it's decreasing on the interval 0 to 9. Well, in order to see if it's decreasing on the interval from 0 to 9, we can do, from the first derivative test, we have these two critical points, 0 and 12. So we do another number line here, and we have 0 and 12. From 0 to 12, I'll just pick a test point. I'll pick, let's say 1. And since from 0 to 12, 9 is already in there in that interval, if I see if this is decreasing, if it's decreasing from 0 to 12, it's definitely decreasing from 0 to 9. So I want to check if it's decreasing. So how do I check? I evaluate f prime at 1. Alright, so f prime at 1. Come here to the first derivative. 1 to the 4th, that's 1. But 1 minus that, that's a negative number. It's a negative number, that's good. If it's negative, it's decreasing. So on the interval from 0 to 12, it's decreasing. Therefore, from the interval 0 to 9, it must be decreasing as well. So therefore, R is true. Alright? So P and R are true, Q is false.